It's just like when we guess on the directions for things. I just screwed up. I just got rid of one of my pictures that I didn't want to get rid of. Let's see if I can undo that. Probably not. Oh well, I'll go back and get it. It's like an educated guess. That's what I was saying earlier. 424, isn't it? Oh, how'd I get so lucky? It's a good little software program right there called Snagit. Pretty handy.
Free?
No, but it's only like $10. It comes. You can get it with Cam Studio. Is how I found out about it. But no, it's not a freebie. Okay, so 24. Well, any questions on the previous one? The only thing that was different about that one was we had to remember to use the 1/3 here. Well, divide the area by 2, right? And then use the 1/3. Otherwise, nothing real earth-shattering there. Okay. So the free body diagram for number 24, again, it's just a beam, so we just have to draw. If I can find my cursor. Oh crap! I found it. All right. Okay, so if we've got this one, let's see. We've got. Oh, but this one is a little bit different now. We do have to account for something different here. I finally got my line straight. Right here's the difference. We've got 400 pounds, but it's going off at an angle. So this is that non-concurrent force, isn't it? So we do have AY. Bless you. And now, AX. I'm going to guess that that's going to the right. And mind you, I wouldn't expect you to guess that, but I'm just going to guess that so we can screw up, so we can see what happens when we screw up. Okay, we guessed the wrong way. I'm telling you that right now. I know for a fact we're guessing the wrong way. Yeah, it's going to the right, isn't it? So you have to have something that counteracts that, and that would be AX. Okay, so, but you'll see that here as we go along. But I just wanted to give you a little heads up. We got 120 pounds here. We know that distance to be 2 feet. Could have made that a little shorter. Okay, we've got an 800 pounder out here somewhere. That's about 10 feet. Looks like 8 plus 2, right? Then I'm going to go in there, now this is how I choose to do it. That is 400 pounds, sine of 60, right? And then I've got 400 pounds cosine of 60. And then finally I've got by. Bx we know is 0 because it's on a roller. And I still need some distances. Well, let's see. 10 and 7 would be about 17 feet, wouldn't it? According to the drawing. And then the total is 20 out to there. So I just write those in as 400 cosine and 400 sine. And remember, if we're going off the horizontal axis, cosine's always x, sine's always y. Okay, and we'll keep it at 90 degrees and we'll all be happy. So let's see, if we do a sum of the forces in the x equals 0, we got ax going to the right, so it's positive, plus 400 cosine of 60. Uh-oh. So if we leave ax where it's at, this goes to the other side of the equation, becomes negative, doesn't it? And that comes out to negative 200 pounds. Therefore, ax really equals 200 pounds to the left. We had said it was going to the right. It came out a negative value, which means the answer is still the same, but it just means you chose the wrong direction. So the real answer is that right there. Then, like I said the other day in class, what I would do, since I don't have an eraser, but actually I do, but if I didn't have an eraser, I would just take all of this and make that look like a big line, and then I'd take this and make that arrowhead go more like that. Plus, then I know I corrected it. Okay? That's all you have to do on that. It's not that difficult. But now, doesn't that make sense? I mean, 400 pounds cosine of 60 was going to the right. There was nothing else to counteract that, to keep it in equilibrium, which is equal to 0. So ax had to be going to the left. Instinctively, I knew that, but I wanted to show you, well, what if I did happen to say it was going to the right, because that's what we talked about earlier, right? If you've got ax, just assume it going to the right. And if you assume it going to the right and it's the wrong assumption, it'll tell you that. The math will work out for you. Okay? The same thing could be said for ay or by if you pick the wrong direction on one of those. It's no big deal. At least after today. It might have been otherwise. So then we'll do a summation of the forces in the y. So we've got ay going up minus 120 minus 800 minus 400 sine of 60, right? That's the y component, plus by pounds. Two unknowns, so we'll do a moment about point A. Okay, and those equal signs are running together on me because of my cursor, so I apologize on that. Well, the 120 is going down, which makes that thing go clockwise, right, which is negative, times 2 feet minus 800, it's going clockwise as well, right, times 10 feet minus 400 sine of 60 times 17 feet plus by, it's going counterclockwise, right, times 20 so now I can solve for by, can't I? Leave by where it's at, everything else goes to the other side of the equation. So I've got 20 by. These all go to the other side. They're all positive, which means that my answer is going to come out the right direction. If you do the math on that, it comes out to like 14,128.9 pounds feet. This is pounds feet, but we're going to make this BY is going to be in pounds. 20 feet divided into 14,128.9 pounds feet should yield you something like 706.4 pounds. We said it was going up. It came out a positive answer. So it is going up. We substitute that in up here. 706.4. Easy for me to say. AY stays where it's at. Everything else goes to the other side of the equation. 120 plus 800 plus 400 sine of 60 minus 706 should give you something like 560 pounds up. Problem solved. The only difficulty there was the fact that you had that force that was going off at 60 degrees. You're just checking your answers, right? Make sure they're all the same.
So in a case like that, how can we tell when we're going left or when we're going right?
As far as,
Like the A of X.
well, in this case, see, you had this, well, AX, you know, is pinned, so you've got to have some kind of reaction in the X direction, okay? But right here is the only thing that makes that X happen. You've got an X component and a Y component because it's not at 90 degrees. So in this case, the force, notice where the arrow is pointing, it's pointing down and to the right, correct? So when I break it out, I make sure that it's down and to the right, okay? If this one's going to the right and that's the only force that's acting on that beam, then AX would have to go to the left to counteract that, to keep it in equilibrium. Josh?
Let me show my visual.
You got to slow down. Remember, I'm
I
old.
know. I'm
Okay.
stuck on that speed. But no, for like A, Y, and BY, I'm just trying to figure out where they are. BY is basically on one side and AY is on the other.
Right. Okay, so AY, see, here's your, whoops, sorry. Get over it. See the A right there?
Mm-hmm.
Okay, and then we got B over here. So those are your reaction locations. Okay, so you've got to have, in this case, since it's pinned, you have to have an AY
Right.
to help, in this case, help hold this beam up. So AY is going to be pushing up,
Okay.
and AX then is going to have to counteract, excuse me, counteract the X component of this force that's off at 60 degrees.
Okay.
If it weren't at 60 degrees, then you wouldn't have any X,
Okay.
because there wouldn't be anything making this thing go left or right.
All right.
And that force, eventually, that force could be just a gust of wind, couldn't it?
Mm-hmm.
If you were looking at a bridge or a building or something like that, you know, or a sign that you're trying to hang, a gust of wind could be what's pushing that to the side, and then you'd have to account for it. Okay? And then, of course, BY is out on this end, and there's no BX because it's on a roller.
Okay.
All right? Anything else? All questions that need to be answered. If you got a question, it's got to be answered. You got to give me a chance to answer it, so that so you can do well on that next quiz. Some of you didn't do so well on the first one, but there's another chance coming up. Okay, so let's see. Let's do